Okay, everybody, welcome to day 7 of object-oriented programming. Today, we are actually going to cover abstraction. Okay, abstraction is the fourth pillar of object-oriented programming. We've got a couple of strategies to achieve abstraction, and hopefully by the end of our discussion today, you will know why and when you'll need to use abstraction. As promised, we've got a little bit of a deviation here. We've got a couple of our classmates here on the line. We've got Kurt, Brian, and Michael here joining us, and from time to time they're going to let me know that they have questions. They'll ask questions. I'll do my best to answer, but hopefully this will deepen understanding by hearing your peers' questions and answers. Okay? So let's go ahead and talk about what we will achieve today. So I'm going to show, first off, I'm going to explain what abstraction is. Then we're going to learn how to achieve abstraction here in C#. We've already talked about abstract classes in the context of inheritance, but we will see how we can use abstract classes to achieve abstraction. We will understand interfaces. We'll know why we should use them. And some sources, if you were to Google pillars of object-oriented programming, would only list 3 because abstraction and encapsulation are somewhat similar, but today we will discuss the differences between them. I've got a code along, and we'll also discuss how we can use abstraction in our movie night application. Okay, so if you were to Google abstraction, you would see maybe Wikipedia as one of your top results, okay? And abstraction, if you read the definition here from Wikipedia, basically says when we do abstraction, we work with ideas instead of concrete things, or we work with models instead of concrete things, okay? So think about an inventor, for example. An inventor may build a prototype of a battleship, okay? An inventor can't have a battleship in his living room, right? So in order to work on the battleship in his living room, he may build a prototype, and it may be scaled down by 1,000 times, okay? This is abstraction. When we remove the concrete thing we are working with and work with a model, or work with an interface, or work with an idea rather than a concrete thing, okay? So a model is an abstraction. Ideas are abstractions. Remember, we said classes are abstractions, right? But abstraction is a principle that we can apply in object-oriented programming that will help us hopefully speed up development. So think of abstraction, the idea, as a concept of on and off, okay? You can see some pictures down here at the bottom of the screen that show different ways that we turn something on or off, right? You've got a little switch with a couple symbols, and those to us mean on and off because you've been taught that. You've got a drawstring, you've got a faucet handle. All of these are using the abstract idea of on or off. Right? We understand the states on and off, even though these concrete objects are very different, right? As I say on or off, you're probably all thinking of something very different, like the power button on your computer, or the light switch, or the ignition on your car. Even the ignition on a car is different. My wife's van has a push button. You have to push the brake and push a button with the key fob in the van, while my vehicle, you have to turn a key. Okay, but all of these things apply an abstract idea, on or off. Okay, abstraction in C# can be achieved in a couple different ways, with abstract classes and with interfaces. Okay, you'll remember that an abstract class is usually a parent class. An abstract class can't be instantiated, or in other words, we can't say new blah, creating an object from an abstract class, okay? And we can, inside of abstract classes, have abstract methods that basically say any child class of this abstract class will have these behaviors, and the behaviors that we guarantee it will have are the abstract methods defined inside the abstract class. Okay, we've got a new structure or type of thing that we want to talk about today, and those are interfaces. Interfaces are similar to classes, but they've also got some differences. And we will see some examples of abstract classes and interfaces right now. But just know that an abstract class or an interface, you could say, gives behavior or guarantees behavior on many different unrelated types of objects. Okay, here's a quick review on abstract classes. So we use the abstract keyword in addition to the class keyword and an access modifier like public. And then inside of an abstract class, we mark methods with the abstract keyword. Then we set up inheritance relationships. So class B is a child class of class A, and class A is an abstract class with abstract methods. All of the abstract methods in class A must be implemented in class B. So here we go. Here is a code example. This should all be a review, right? We've got a car. That's an abstract class. We're saying that all cars have a start method, and you'll notice the abstract method here has the abstract keyword and no method body, or in other words, no open and close curly braces, right? That's on the left-hand side. On the right-hand side, we've got a Jetta class. A Jetta is a car class. We've set up an inheritance relationship here with the colon, okay? And we have inside of the Jetta class a start method. This start method does have a body, okay? So you can see how anything that is a car, anything that is a child class of the car abstract class will have certain behavior, and that behavior is start, right? You can see that we tried to break that rule in the bottom screenshot there. We said a Mustang is a car, but we did not include a start method. And the C# compiler starts yelling us saying, hey, if a Mustang is a car, it must have the behavior start, okay? So just like on and off is an abstract concept that is implemented by things like a light switch and a bathroom faucet or a computer power button, start is our abstract behavior. Stop could be an abstract behavior, and we say that anything that is a car will have start and stop functionality, okay? And this is how we take an abstract idea and give that that abstract behavior, we guarantee that it will be on any child class. Okay, are there any questions up to this point?
Hey there, Ben, I've got a question. This is Kurt. So in this example, I see on the left, there's public abstract string, and then on the right, there's public override string. So this is basically, for me to understand the relationship, can you kind of tell me why those two differences, the abstract versus override? Is it because it's inherited?
Yes, it's because it's inherited. You'll remember our day on polymorphism, we also declared methods as virtual and the child in the parent, and then the child classes had override, right? And the relationship is basically the same. We have the functionality in the parent, but the child class wants different behavior. The relationship is just a little different here. When we say abstract, we're saying there is no behavior in the parent, so the child has to provide an override, right? So very easily we could sub out the words abstract for virtual in the car class, and override means I'm providing my own way of storing or getting the VIN, and I'm providing my own way to start in the Jetta class. Does that answer the question?
Absolutely, thank you.
Okay, moving on. So let's talk interfaces. This is the new structure that we haven't used up until this point, but I guarantee you that if you can master interfaces and know when to use them and explain when to use them, you will have a very long, fruitful, lucrative career as a software developer, okay? So many principles that are good practices for software developers depend on you understanding what an interface is. Okay, think about an interface as as a panel, okay? You could have a panel with a big red button and a big green button. And behind that panel, there are some wires. I'm no electrical engineer, and I know Eric Tang is laughing at me somewhere, but imagine this panel being put on a washing machine, right? It would be very easy to know how to operate that washing machine. To start it, you push the big green button. To stop it, you push the big red button. That panel could also be put on the dashboard of a car. That panel could also be put on a popcorn machine. That panel could be put on a television. That panel could be put on, I don't know, any number of things, okay? That panel is like an interface. An interface can be put on any class, okay? The difference between an interface being put on a class and a parent and a child class inheriting from a parent class is that the child class can have multiple interfaces, or in other words, a TV could have multiple panels, but it would still just be a TV. It wouldn't be, it's not an is-a relationship. It kind of is, but it's not an inheritance relationship is what I should say, okay? So hopefully that panel analogy makes sense. The way we implement interfaces, or the way that we make our classes have these interfaces or panels, is very similar to inheritance. You can see here in the example that we use the colon, okay? The colon is also what we use when setting up an inheritance relationship, okay? When we define an interface, we give it an access modifier, public, private, protected, internal, or so forth, right? Instead of using the class keyword, we use the interface keyword, and then we give it a descriptive, unique name, just like we would with a class, okay? So classes implement interfaces, and this is an is-a relationship, but it is not inheritance, okay? So let's take a look at just exactly what this means. Here is an interfaces example. You can see we've got this abstract idea of on or off. An important thing to note about interfaces is there can never, ever, ever be an implementation in an interface. You should not see curly braces for your method bodies when defining an interface. You can see the interface here called I toggle on off. Okay, it's not a requirement that interfaces start with I, but it is a best practice that a lot of shops use. Like here at Health Equity, we try and make our interfaces descriptive by beginning them or prefixing the name with I and then describing what it does. So it almost reads like a sentence. I toggle on and off. Okay, we say public is the access modifier we use. We have the interface keyword. We give it a name, open and closing curly brace. And then we've got some methods. Okay, we've got no access modifier. So this is important. Interfaces do not define the access modifier. When we implement an interface on a class, that's when we say this is a public or this is a private method. Okay, but it doesn't make a lot of sense to have an interface or a panel for a TV be inside the TV, right? What is the point of a big green button inside the TV? Or in other words, we probably, when something is an interface, it probably needs to be public or accessible to the outside. Okay, that's defining an interface. No method bodies, but we're saying anything that implements the I toggle on off interface. We'll have an on method and we'll have an off method. So we've got a light switch and a pull string class. Both of those implement the I toggle on off method or interface, and you can see that because they implement those interfaces, there are two methods, on and off, right? And both of those inside of the light switch and the pull string class have method bodies. They have the open and closing curly brace, and inside we've got some functionality, okay? So this abstract idea of turning on and off is an idea that you can interface with when dealing with a light switch or a pull string. Okay, does anyone have any questions at this point?
I do again, sorry. The public interface, I toggle on off. Why is there not a public abstract interface there? Why is it written this way?
Yeah, great question. So when we define classes, they can either be regular classes or they can be abstract classes using the abstract keyword. Interfaces are always abstract. Interfaces can never have an implementation, right? Interfaces are just the panel and the wires coming off of the panel. They can never have any functionality defined in them. While on the other hand, abstract classes can provide the same functionality as an interface with abstract methods, but in addition to that, abstract classes can have some functionality in them. Or in other words, an abstract class can have methods that are not abstract, right? So an abstract class should be used when you want to guarantee behavior and pass down some behavior to the child classes, but an interface should be used when you only want to guarantee that a implementing class has certain behavior. Does that make sense?
Yes, it certainly does.
Right. So short answer, interfaces are always abstract. Classes can be abstract. When you want it to be abstract, then you use the abstract keyword, but not necessary for interfaces. Okay. So when we covered inheritance, we said that a class could have one and only one direct parent. Okay, we could set up a parent-child, grandchild, right? We could create a chain of classes that inherit one from the other, but there can only ever be one immediate parent. This is not so with interfaces. A class can inherit multiple different kinds or multiple different interfaces. For example, think of the abstract concept of controlling temperature, right? Now think of the furnace or the thermostat that controlled the furnace in your grandparents' home, right? In my grandparents' home, it was a round knob on the wall with a dial, and you turned the knob to a desired temperature. There was a needle that pointed on a round scale to the desired temperature, right? So that is a thing that will turn the furnace on or off as well as control the temperature, right? Now, think of your dream home and the thermostat that will exist therein, right? Maybe you want a Nest, and the Nest doesn't have a dial, it doesn't have the round knob on it. Rather, it's got a digital display, right? And the digital display has an up key and a down key to control the temperature. When you press the up key, the digital display shows a new number that is 1 degree hotter than before you pressed the up key, okay? But this thing also controls the furnace going up or on or off, and it also controls the temperature going up or down. So these two abstract ideas, on and off, and temperature control, apply to the thermostat in your grandparents' home and the thermostat in your future dream home, okay? So a furnace can have both of those interfaces. It could have even more interfaces. Think of many panels on your TV, one to control the power, one to control the volume, one to change the channel, one to change the brightness. All of these things could be multiple interfaces. And the way we achieve a class implementing multiple interfaces is still with the colon, but after the colon, it's a comma-separated list of interfaces. Okay, so over here, you can see our example, I toggle on off, I control temperature. Those are two interfaces that we've defined. I toggle on off has on and off, just like last example, but I control current temperature has two methods, get current temperature and change temperature to, right? And it's got it accepts a degree setting saying change the temperature to this degree setting. Okay. On the right-hand side, we've got the furnace class, and it implements two interfaces. So you can see furnace, colon, I toggle on off, comma, I control temperature. These could be in any order that you want. The important thing is that the furnace class has an implementation for on, off, get current temperature, and change temperature to, okay? So you can see, hopefully, that a class can implement multiple interfaces. Are there any questions at this point? I forget that I'm on webcam. Sorry for itching my ear. Oh, what a goofball. Sorry. Hopefully I haven't picked my nose.
We'll fix it in
Okay.
post.
Thank you. Thank you. Let's
There is
talk
no
about
post.
the benefits. Oh, well, sorry, everyone. Enjoy the food truck rally. Okay, let's talk about some of the benefits of testing with an interface. Okay, let's say that there are two software development teams that need to build a really important piece of software. Okay, and these pieces, the piece of software is going to be broken up into two different programs or sets of classes or whatever you want to call them. Okay, these two teams can work in a couple different ways. Team A could complete all of their code first and then hand it off to Team B, and Team B could look at the code that Team A wrote and write code to interact with Team A's code. Sorry, 1 second. Can you pause the recording? Oh, never mind.
Yes, give me just one. Oh, no?
Oh, no,
Right.
no worries. Don't pause.
All right.
Yeah. Okay. So Team A, Team B could work together in multiple ways. Team A finishes their code. Team B then writes code to work with Team A's code. But as you all know, we want to get the project done faster, right? So we want Team A and Team B to write their code at the same time. So what they can do is come together and say, hey, Team A is going to develop some code that will implement this interface. We don't know how we're going to do it yet, but we know that we're going to have a method called getData, and we know that we're going to have a method called saveData, and those two methods will take objects of type popcorn DTO, right? So we can create this interface. Team B will use the interface. Team A will implement the interface. So once the interface has been decided, it's like a contract, right? We know that we're going to work towards this contract. So we can both go on our sides, respect this contract, and Team B will write code that uses that contract. Team A will write code that implements that contract. And the same is true with testing, okay? Something that you will do as a developer is you will need to write tests. And maybe it will happen that you want to write tests before you build your functionality. Okay, in order to do this, we need to use interfaces, right? In addition, maybe you write code that writes data to a database, right? And when that code is used in your app, it should save data to a database. It should retrieve information from a database. But maybe you want to write some test code that doesn't depend on a database. Maybe you want to write some test code that doesn't interact with the database because maybe your tests don't run in an environment where they have access to the database. So maybe we build a interface that says save data, and then we have two different classes. One is a production database data saver, and it implements iSaveData, right? Then we have another class, test save data to a file, that implements iSaveData. Okay, this is a very common technique. We don't want our tests to leave lasting pieces of information in the database, so we write an interface and we swap the interface, or we put the interface on a fake object to mock the behavior that our production application does. So here's an example from last time I taught object-oriented programming, where we dealt with building soldiers, okay? So let's say we have a soldier. This class has all of the information that you would need and the behavior about a soldier, right? It uses a console writer to display stuff to the console. But now it's time for us to write some tests around the soldier, okay? And we don't want our tests to have to get data from the console. Writing code to scrape data from the console is icky, right? So instead of writing stuff to the console like it would in the production application, we want to save data in memory and then have a way to get that data out of memory so that we don't depend on the console in the context of our test. Okay, so a way we can do this is by creating an interface. I manage output. Okay, IManageOutput is implemented on the console writer. So let's see what this looks like. I have an interface here called IManageOutput, and you can see here it's got a method, and this is all abstract. We know that we're going to write output, and it accepts a message, which will be the output. Okay. Now we create two classes. One of them is the console writer, and it simply writes stuff out to the console, just like we would expect our application to do. But we've also created a fake console writer class. It also implements IManageOutput. And rather than depending on the console.writeLine method, it saves stuff to a string. Okay, and this string can be used at the end of our test by calling a getOutputStream method. So one of these classes uses the writeOutput method to write output to the console. The other uses the writeOutput methods. Notice they have the same exact signature, but it does things differently. It saves it to a string in memory and gives the consumer of the fake console writer class a chance to get the information before it's dumped from memory. Okay, here's the soldier class. The soldier class has a property, you can see up here at the top, the output manager, and it is of type IManageOutput. And you may be saying to me right now, but Ben, how can I have a variable that is of type and interface? I thought I couldn't create objects from classes. And you'd be right, you aren't creating an object from an interface, right? You are creating an object that is either a fake console writer or a console writer, but because implementing in interface is an ISA relationship, that means those are both of type IManageOutput. So it's kind of like inheritance where it's an ISA relationship, but you could never say new IManageOutput. You'll notice here that the constructor takes in an object that is of type output or IManageOutput. You can notice that the thing that calls the constructor right here accepts either a console writer or a fake console writer. Okay, so both of these are an IManageOutput, right? And you notice here that the left-hand side depends on the console writer to call the fight method, and as it fights, the console writer outputs information to the console. However, the fake console writer just stores it in memory in a string variable. And I can get the value of that string variable by calling getOutputStream. You can see here on the right-hand side in my test, right? So fight uses the output manager that is of type IManageOutput and just does output, okay? So you can see here that it is very easy for me to swap out the type of thing or the thing that I'm working with because they both implement the same interface. Are there any questions at this point? Okay.
I think I'm all right.
Okay, sounds good. So let's talk a little bit about encapsulation and abstraction. Okay, you can see this lovely graphic here that shows under the hood of a car and has an arrow saying encapsulation. And we have another thing that's pointing to like the general car, right? Abstraction. So encapsulation is hiding unimportant details, exposing important ones. And abstraction is giving a common way to interact with a thing, right? So abstraction in C# is accomplished with interfaces and abstract classes. Encapsulation is accomplished with access modifiers and good design, like creating an on method and not open fuel injector valve and spark and rev the engine. I don't know. I'm not a car guy. You already know that. Okay, so abstraction, I know how to use an object without knowing how it does its thing. And encapsulation makes it simple, right? So abstraction is I'm working with an abstract idea. Encapsulation is it's easy to work with this thing. Okay, and a couple more examples of abstraction and encapsulation, but just know that abstraction is I can take an idea, I can work with multiple objects, Encapsulation is I've hidden the unimportant details, I'm protecting my state, and I've only exposed the important details. Does anyone have any questions at this point? Okay.
No, that's good.
So let's write some code. Okay, we've got a couple different things that are going to do the activity of mining. Okay, we've got a miner, a steam shovel, and a very futuristic laser used in mining, right? All of these things are going to displace dirt and discover treasure. An 1800s era miner is going to do it a little less efficiently than a 1900s era steam shovel, which will be outclassed by a laser. Okay, but all of these are going to implement an interface, I mine. Okay, and you'll see how as time progresses, we can swap out a miner for a steam shovel and then a steam shovel for a laser. All right, here we go. Let's pop in to Visual Studio, and I'm going to go ahead and do a new console application. I'm going to call it mining fun, because this will be fun. Okay, very first, let's go define our classes and our interface. So we've got a miner, a steam shovel, and a laser, and an iMine interface, okay? So I'm just going to define them here in this same file. Probably not a good idea for your real apps, but it's easy. So I'm going to come here and say public class miner. Then I'll create a class for the steam shovel. And the laser. All right, we've got those three classes now. So let's create our interface. What behavior is shared by a miner, a steam shovel, and a laser? Sounds like the start of a really lame dad joke, right? But to begin with, let's go ahead and say public interface I mine for gold. Okay? And a thing that mines for gold, right? Stepping away from a miner and a steam shovel and a laser and just thinking about any old thing that could be mining for gold, there's some activities that it should do. For example, public, let's remember we don't do access modifiers. Bam. Let's go ahead and do int remove dirt, right? When we dig, we're going to remove dirt, and we'll say yeah. And we do not give it a method body, okay? If I were to try and give it a method body here in an interface, I'd get yelled at. Interface members cannot have a definition, meaning an interface is always 100% of the time abstract. I can't put method bodies in an interface, okay? Then once we've removed dirt, we want to check the ore for gold. Pool ore contains gold. Okay, so let's go with those two methods for right now. I'm ready to say that a miner, a steam shovel, and a laser will all do these activities. So it's time to implement the interface. I'm going to come here to my miner object and implement the interface. It looks exactly like inheritance, right? I use the colon and then I have my interface, but you can see here that Visual Studio is yelling at me and prompting me to do some things. So it says that my miner class does not implement the member remove dirt, and it does not implement the member or contains gold. So I'm going to go ahead and use Visual Studio to auto-generate the methods that we need. Okay, so it went ahead and did the ore contains gold and the remove dirt. Okay, And right now, we are going to just say yes, ore contains gold every time. This is California in 1849. Okay, remove dirt, and we will return the amount of remaining dirt, which can be measured in 100, whatever that means. Okay? So we have said that a miner will have the behavior that an I mine for gold object should have. And those two behaviors are remove dirt and ore contains gold. All right, same deal. I can come here and implement this interface. Visual Studio yells at me and says, you did not implement the interface members. I implement them. Here we go. So steam shovel is clumsy and can't check for gold, so we're always going to return false. And remove dirt. Steam shovel is very effective at removing dirt though, so it does so much more dirt removal than a miner. Okay. Finally, a laser. All right, a laser can detect gold, but only in the evening. So we're going to say if datetime.now is greater than, no, datetime.now.hour is greater than 20, or in other words, if it's after 8 p.m., then we will return true. Otherwise, we will return false. All right, this is a super silly example, but I just want to drive home that the behavior is very different on these three classes for ore contains gold. But I don't care because I am going to consume these three classes and the interface will stay exactly the same. The panel on a miner and a steam shovel and a laser are exactly the same. I know how to check to see if the ore contains gold because the method is the same no matter what the class is. So let's write some code now that uses, oh, lasers are extremely efficient at removing dirt. None remains. So let's write some code that uses a miner, okay? So I'm going to come here and say var thing that mines, and I'm going to say new miner. Var another thing that mines the new steam shovel. Yet another thing that mines is a new laser. Okay, all of these are different types. A miner, a steam shovel, and a laser. Remember, implementing an interface is an ISA relationship, so all of these, in addition to being their own separate types, are also of type I mine for gold. Okay? So I'm going to come here, and inside of this class, I'm going to create a method, public static void do mining, and it's going to accept something of type I mine for gold. Digger, why not? Okay, digger dot remove dirt, and then digger dot ore contains gold. Okay, I've got my three objects here. I've also got a method that accepts something of type I mine for gold, right? Because a miner, a steam shovel, and a laser all have the I mine for gold panel. Now I can make a call to do mining, and Visual Studio yells at me and says, hey, you didn't provide for me something of type I mine for gold. All right, I've satisfied it here. So we're passing in a miner. A miner is going to remove dirt and is going to check to see if ore contains gold. right? And everybody's happy. But now 100 years pass and it's time to replace a miner with a steam shovel, right? Same deal. Even though a steam shovel and a miner are very different objects, they have the same behavior because they both implement the same interface. Fast forward another 100 years, and it's time to use a laser. And I can do that. Visual Studio is happy because all three of these things are of type I mine for gold. Does anybody have any questions at this point? Okay. So jumping back to the slideshow, let's talk about how we could use abstraction in our movie night app. So think about the word reservation, okay? There are a couple different types of reservation that are not very related. For example, a culture club member is going to get on the phone and talk to the manager of the theater and say, I want to reserve 14 theaters on these 2 dates, okay? So that's a reservation. It's an idea of saving a resource for the future, right? A team member interfaces with the culture club and they say, I want to reserve 4 different tickets. So even though it's very different, even though reserving a theater is very different than reserving a couple of tickets, the idea of reserving is the same, okay? So we could create I reserve stuff interface, and we could use it when modeling reserving a theater, a culture club member calling a theater manager to reserve a theater, or we could use it, that same interface, when it's time for a team member to reserve tickets, right? Using interfaces is good because it gives us a common way to interact with an object. Okay. Any closing questions before we end here?
I think I'm feeling all right.
Okay. Well, thanks everybody. I'm hoping that we'll be able to do a little more abstraction practice next week. So, sayonara.
Sayonara.